Hello students, welcome to the next session of Centroid. This is Professor Vidyasagar Mugi. Today I'll be continuing the session on how to solve the problems on Centroid. So this is the most easiest way to approach the problems on Centroid. So let me quickly recall you about the previous sessions in which we discussed what is Centroid and the different derivations on some geometrical shapes and their centroidal values. So from the last session we have derived relations of centroid for rectangle, semicircle, triangle, quarter circle, some basic geometrical figures. So using those relations we'll be solving the problems on centroid for some compound lamina sections. Right, what you see in front of you is a T section. Right, so T section, do we have any direct relation to find out the value of x bar and y bar for T section? No, we haven't derived such. So what we can do here to get what is the value of x bar and y bar for this particular T section, this is called as T section, where this top part is called as flange. This is called as flange. If I draw one more T section here, this particular top part is called as flange and this is called as web. This is called as flange and this is called as web. Now this particular T section we cannot directly arrive at the value of x bar and y bar. So what we can do here is we can divide this into known geometrical shapes. So what are the known geometrical shapes that we can arrive at this T section by dividing it into sections? So it is we can divide this in such a way that if I join this line here, this flange becomes one part and this web becomes one part. Now when I separate these two separately and I take out these two separately, what is the shape of those? So the shape of those will be what? It will be a rectangular shape. Right, so if I find out the centroidal value of the upper rectangular shape and the lower rectangular shape, then I can, if I add them, then adding them I'll get what? The total centroidal value of this T section. So firstly what we'll do is, okay, step 1 reads, it reads that identify the symmetrical axis. If no symmetrical axis is given, choose them as a reference axis. Now select the left hand bottom corner of the given figure as the origin so that the entire figure lies in the first quadrant. Now when I was discussing centroid, I also told you that when we are fixing the reference axis, we have to select such that the object falls in the first quadrant. So the reason was what? To avoid the negative centroidal values. Now if you see the given figure here, this is T section. So firstly, since there is no reference axis given, what I'll do is I'll first fix the reference axis for this. Now the reference axis, what he has told, we have to select such that it should fall in what? It should fall in the first quadrant. Now where should I draw the reference axis? I should draw it in the left hand side. Now when I draw the reference axis, see this very carefully. So the reference axis should be such that the y-axis should exactly pass through the object here like this. You have to fix the y-axis here such that this object touches here. Right, this distance is what? 0. Similarly, when you draw the x-axis, it should touch the bottommost part of the given lamina. Now this is what is the reference axis for the given figure. Now this reference axis I'll denote it with capital X and I'll denote this as capital Y. Now this is indicated with the arrow mark. Now hope you are clear with finding fixing the reference axis. So reference axis is such that this is falling in the first quadrant. Now from this reference axis you have to locate what is the value of x bar So x bar is with respect to what? Y axis, y reference axis, and you have to look at what is the value of y bar, and that is with respect to what? X reference axis. Now from the figure you can see that the dimension given, the flange width of the flange is 120, thickness of the flange is 10 mm, height of the web is 60, and thickness is 10 mm. Now this is the first step. In first step, what is the thing? You have to fix the reference axis, right? So that is the when such that it falls in the first quadrant. That is your first step. And second step, what is second step? He says subdivide the given figure into known geometrical shapes. Now T section, since we don't have any relation, what we'll do is we'll split it such that we can form them with the known geometrical shapes. Now what are the known geometrical shapes? So these will be the known geometrical shapes will be one rectangle and one rectangle. So subdivide the given figure into known geometrical shapes. So divide, and after when you divide, the next step is identify their individual centroid by denoting them with small gin, where I refers to number of subdivided shapes. Now will be the number of subdivided shapes for this particular figure. It will be 2 numbers. So if I mark this as element 1 and if I mark this as element 2 after joining here, so you have to draw it such that this is the reference axis now again. So I'll draw the reference axis for subdividing the element. So this is the first, this is for the first figure, and this is for the second figure. Now what is the second step that I am going to do here? In second step, I am going to fix. Now what is the first element? This is the first element. Now how far is this first element from this point? We don't know. Can we calculate this? Can we calculate this? So I need to calculate what is this distance, because I know CG of this. What is this distance? I need to calculate this. So total distance is what? 120. This part is touching here. So out of 120, if I divide this with 2, what I'll get? I'll get half of this. So I'll divide 120 divided by 2. So how much I'll get? I'll get 60, right? So 60 is what? It is up till the center of this. But what I want this center, this distance. So 120 from this, what I'll do is I need this distance. So what I'll do is I need this distance. So from 120 I'll minus 10. So 120 minus 10, how much I'll get? I'll get 110. So 110 is what distance? Leaving this 10, it is the distance of this and this together. But I want only this. What should I do? I should divide this with 2. So what I'll get? I'll get 55. So what is this length? This is 55. Right. Now I should draw this first element at what distance? I should draw it at distance of 55 from reference axis. So this element I'll just roughly draw it. So this is the first element now. So first element is the known geometrical shape of rectangle, so such that its bottom part is touching the reference axis. Now this small element is having its centroidal part. So now we can apply the formula for this rectangular shape. So what is the value of x1 y bar for rectangular element? So x bar is what? It is b by 2 and y bar is d by 2. Now what is value of b and d for this element? So value of b is 10, value of d is 60. So this is 10. So what is half of 10? It is 5. So the distance of the element from its center, so we can plot it like this. What is this value of x1? So this point what I was talking is what is g1, representing it is what? G1. So what is this? This G1 is the centroid of only this rectangular component, right? When I separated this, this is the rectangular component and its centroid is what is represented as G1. What is its value from here? What is value from here? It is what? So I already know what is this distance. I know this distance. What is this distance? This is 55. How did we get that 55? Here, 120 minus 10 divided by 2. We got 55. But I want distance from where to where? From this y reference axis to center of this element. How will I get that? So how much is that distance? That distance is 55 is from reference axis to the outer part, plus what I should add? I should add, what is the formula for rectangular element to find x bar? It is b by 2. So b is what? 10 divided by 2. So how much I'll get? I'll get 60 mm. So this is what? This value I'll represent it as x1, because it is with respect to what? Element 1, as I marked here 1. So 1. So I'll mark this as x1. Similarly, what will be the value of y1 here? I'll call this distance from y-axis as y1, which will be equal to what? So what is the total distance? This is 60. This is 60. What is the formula to find y bar for rectangular element? It is d by 2. How much is d? 60 divided by 2. How much is this value? This is 30 mm. Understood this part? Okay. Now moving on to the next element. Now where is this next element? This next element is at some height from the base. It is at what height? So it should be represented such that one left part of this is touching the reference axis. That is how we have drawn the reference axis with respect to the main figure. Right. Now this second element is here. So this is the second element. So total height is what? So what is this length now? So this distance is what? This distance is here. So this is at a distance of 60 from what? X-axis. So this is at a distance of 60 from X-axis. And again, this particular rectangular element has its own centroid. So this is represented like this. So what is this value of centroid? I'll represent this as G2. So what is this distance? So what is the distance of this x bar? So this value is here. So I need to calculate what is this distance. What is this distance? I need to calculate this particular distance. Yeah. Let me draw this line. Okay. Now, okay, concentrate. This height is 60. Again, what is the thickness of the second element? Now only look at the second element. Thickness is 10, width is 120. Now what is the formula again to calculate the x bar value for rectangular element? B by 2. What is B for this? Total is 120. X bar is what? B by 2. B by 2 is how much? 120 by 2. How much you are getting? 60 mm. You are getting 60 mm. Then what is value of this is what? This is x2. Then similarly, what is y2? Now calculate what is y2. Y2 is from here to here, it is 60. Then what is this thickness? This thickness is 10. So this is 10. You see here, this is 10. So what is y bar for only rectangle? Y bar is d by 2. D by 2 is how much? 5. So what is the total distance from reference axis? It is 60 plus 10 by 2. So how much is the answer? It is 65 mm. It is 65 mm. So we got what is value of x1 y1, what is value of x2 y2. So when you get this figure, you have to divide in such way and locate their individual centroid. So once you find out the individual centroidal value, that is g1 g2, right? Now what we will do is we'll combine them. So why is this procedure followed? You will get to know when we complete this problem. Hope you understood up till here. Moving on to step 3. Okay, in step 3 what you have to do is we have to enter the values in the tabular column as shown. So this is a tabular column where you have to enter the values. The columns are divided into 6 different columns. So first column is component, second is area of that, third is centroidal distance from y-axis. So this y-axis refers to the reference axis of y. Centroidal distance from x-axis, again it refers to the centroidal distance from reference axis x. Then you have to add area into x, area into y, and write those here. So capital A or summation A both means the same. Now what is the first component? So first component is called as rectangle component. Because the shape is rectangle, I will call this as rectangle 1. Second component is what? Rectangle 2. So both the known divided shapes are what? They are of what shape? See here, they are of what shape? Both are rectangle. So rectangle 1, rectangle 2. Now what I will do is, what is the area of rectangle 1? How will you calculate the area of rectangle 1? So formula to calculate area of rectangle is length into breadth. So what is length? Or B into D. So width is 10 and depth is 60. So what is the area here? So for first rectangle, 10 into 60. So this you have to be very careful. Whichever element you have marked first, you have to write those components here. So 10 into 60. What is the area of second element? Width is 120 and depth is 10. So this is 600 mm square. Area is mm square and this is 1200 mm square. Now what is the centroidal distance from y-axis? When I say y-axis, you have to refer these values. So with respect to y-axis, the distance is what? x1. From y it is x, from x it is y. So from y x1, y x2. So write those values here. Centroidal distance from y-axis, first one is 60 and second one is also 60. After this, centroidal distance from x-axis, this is 30 and this is 65. This is 30 and 65. See here, y1 is 30, y2 is 65. Now what is the next step? So next step is just a mathematical calculation. A into x means what? You have to multiply area 600 into x. So this will be 600 into 60 and this will be a into y, 600 into 30. So 600 into 30. Similarly, this is 1200 into 60 and this is 1200 into 65. So multiplying this, you will get this as 36,000. This will get as 18,000. This will get as 72,000. This will get as 78,000. Now the next step is you have to add area A1, A2. So because this column is for what? This column is for total area. So total area summation A is equal to what? 600 plus 1200. It is 1800 mm square. Similarly, you have to add A into x. So this will be what? Summation A into x. This will be summation A into y. Now why you require the summation A into x and summation A? You go back to part 1 of this video where we have derived the mathematical relation for x bar and y bar. So what are those mathematical relation? So x bar stands for what? Summation A into x divided by summation A, whereas y bar stands for summation A into y divided by summation A. So that is the reason why we calculate this. Now this is 1800. So add 72,000 plus 36,000. So this you will get as this is 7 plus 3 is 10, 1 lakh. So 108,000. So this is the value. Then for this it is 78 and this is 96,000. This is 96,000. So we got A into x, A into y, and what is area. Now calculate what is x bar. So x bar will be what? Summation A into x, which we have calculated here. It is 108,000 divided by 1800. So what you will get? You will get this value as 60 mm. So what does the meaning of this? See here, when we are calculating value of x1, x2, there are also 60 and 60 and x bar is also 60. Means what? The element is symmetrical about y-axis. Right. Now what is the value of y bar? It is 96,000 divided by 1800. So this you will get 53.33 mm. So we calculated what is y bar and what is x bar. So these are the answer. So very simple problems. So if you solve this, this is for 10 marks. Then after you calculate what is x bar and y bar, represent those by drawing a figure. So from reference axis, value of x bar is what? 60 mm and value of y bar is 53.33. So this is the procedure of solving the centroid problem. Hope you followed this problem. Any doubts, please feel free to ask. So practice more problem. So in the next session I'll be taking some more problems on centroid which will clear out your difficulties. Okay, so thank you very much.